Good morning, students. Today we will see the topic rectilinear motion of particles. This is coming under kinematics of particles module. So I am Dr. Auriki Selvakumar, a Senior Associate Professor, Design and Automation Research Group in School of Mechanical Engineering at Vellore Institute of Technology, Chennai. So we are having different types of motion. So one is vibratory motion, then linear motion, then curvilinear motion, oscillatory motion, circular motion, and rotary motion. So this is an example of uniformly accelerated rectilinear motion. So one by one we will see in detail in this presentation or in the forthcoming classes. So the first one, rectilinear motion of particles. So you can see that objects are moving in a straight line. So you can see the bus, cars that are moving in a straight line. And similarly in the below diagram you can see the dollar walking in a same linear direction. A particle moving along a straight line is said to be in rectilinear motion. So the only variables we need to describe this motion are the time, that is denoted as t, and the distance along the line, that is denoted as x, the x as a function of time. So these variables are important to describe the rectilinear motion of particles. So further, with these variables, we can define the particle's position, velocity, and acceleration, which completely describe the particle's motion. Okay. The variables are, that time and distance. So when we study the motion of a particle moving in a plane, that is in a two dimension, x and y, or x and z, or y and x, so any two perpendicular axes, okay, or in a space that is three-dimensional, we will use a more general vector rather than simply the distance along a line. So next one is position from a fixed origin. So just go through this diagram, that A and B. You can see, take the O as an origin and the P is the moving point. So at any given instant t, that is time, a particle in rectilinear motion occupies some position on the straight line. That's very general. Okay. So based on the time, the particle will occupy any one position in the straight line. Okay. To define the particle's position P, we choose a fixed origin O on the straight line and a positive direction along the line. Okay. So you can see this is the fixed origin and this is the point P. It is in a positive direction. But if we come to the figure B, so P dash, it is in the negative direction. So the positive or negative direction, it depends on the motion of the or movement of the particle. Figure A denotes the positive position coordinate and figure B denotes negative position coordinate. Next one, further in detail, we will see what is positive or negative sign. The same figure I am taking. So we measure the distance x from O to P and record it with the plus or minus sign. That's the general one. According to whether we reach P from O by moving along the line in the positive or negative direction. So you can see here now, so the O is there and the P, it is coming towards right side of the screen, and this value is x, that is in positive. So when you take P dash, which is coming in the left side of the origin O, so it is moving in the negative direction, that value is x dash. Next one important term here is supposition coordinate. So take this same figure as a reference. The distance x with the appropriate sign completely defines the position of the particle, as said in the earlier. Okay. So it is called the position coordinate of the particle. So in the figure A, so O to P, that is it defines the positive direction and the value is x. Okay. So that is positive position coordinate. In the figure B, you can see that the O to P dash, that is the distance x dash, so it is defined as a negative position coordinate. Further in detail with the numerical value, so the position coordinate corresponding to P in figure A, so you can count it, it is 1, 2, 3, 4 and 5, so the distance is 5 meter. Here 1 unit is 1 meter, so it is 5 meter. Similarly in the figure B, if you see the coordinate corresponding to P dash is from O, it is 1 and 2, it is -2 meter. So you can see here O to P, it is plus 5 meter. Then the O to P dash, it is O to P dash, it is -2 meter. So next one is small displacement. The term, what is small displacement? Okay. So now see the figure, a small displacement del x from time t to time t plus del t. So now consider the position P, okay, from O to P you can see that is the distance x. So now you can consider the position P occupied by the particle at time t, okay, and the corresponding coordinate as x. So already we have seen this. So next one, consider also the position P dash, okay, occupied by the particle at a later time with a small variation in the time, okay, that is t plus del t. Del t is a small variation in the time. We can obtain the position coordinate of P dash by adding the small displacement del x to the P coordinate. So based on the figure you can see that from O to P the distance is x and P to P dash is the small variation in time. According to that there is a small change in the displacement, okay, that's only we are calling it as a small displacement from P to P dash. So how to get the distance of P dash is if you are adding the x with the del x you will get the distance. Similarly the time is if you are adding t with a small change in time del t you will get the time with respect to the origin. So if you refer the figure, then you will understand much better. You can see the point O, and this is after t time. That is the point is P obtained. The distance is x. So now you can see after a small variation in time, that is delta t, the point obtained is P dash, and the small displacement is del x. Thank you. Further, we will see in the next class.